Okay, great. Recording started. Okay, you had the idea for this. Do you want to kick us off?
Yeah, sure. So thanks for joining us. And today's topic is about folios for anonymous memory. And for us, for Google, 90% of more than 90% of our memory usage is anonymous. So we are thinking how we could leverage the benefits of folios. And the background is generally for low-end devices like Chromebooks, Android phones, huge pages help. Generally, they improve performance without memory pressure, but when under memory pressure, and they also hurt performance because of internal fragmentation. Also, there's no guarantee that we always can allocate huge pages because of external fragmentation. So we are trying to find some middle ground, which generally we want to use something between 2 megabytes and 4 kilobytes. So at least for Chrome OS, the best page size is 32 kilobytes. And even for some user-space memory allocators like tcmalloc, it is aware of huge pages, but still there's more than 10% of internal fragmentation. That means if we give it a 2 megabyte page, it's gonna waste like 10% of it. And for user space page memory allocator that are not aware of huge pages, the internal fragmentation is even higher. So I'm not sure for servers. I'm not sure you guys use in-memory cache like Redis, memcached. And basically, if you do, when you start those applications, it gives you a warning if huge page is set to always, because for those applications, they create high internal fragmentation, and using huge pages actually hurts performance. The average, I think I saw a report on the average size of payload for those applications. Generally, it's around about 700 kilobytes. So if you just give it a 2 meg page, then I don't know. I just say the internal fragmentation. I don't have a exact number, but I just say it's quite high. So for anonymous pages, if we don't use, if we just move forward with this idea, with this medium size page size idea, we could, at least theoretically, we could run into a lot of troubles with tail pages because at least at the moment, we don't have anything that is type safe. I think I think that's one big advantage we could use from Folios. And I know there's strong disagreement between FS developers and memory management developers on how we can move forward. But I think while we're here, why not just see if Folios for anonymous memory is a reasonable use case, or is something that we all think about it, but no, we haven't really discussed it.
One question. So you said that you see improvement, like the sweet spot is about 32 kilobyte pages, but where improvement comes from? So if you don't mark it as huge, is it a review or where the benefit comes from?
Oh, the improvement comes from basically we allocated 32 pages in one batch. We mapped in one batch. That's only one page fault.
Okay, so just batch. Okay, I see.
Yes, right. Also, it also reduces external fragmentation because instead of allocating 4K pages from different regions, we could allocate 8 contiguous 4K pages. That would make allocating 2 mega pages easier, theoretically.
Okay. So I'm not sure that so for page cache, what Matthew did is he grows like read ahead window, like when read ahead hit, and this way increase like page size or next allocation. I'm not sure that it's good idea for anonymous memory, because like for anonymous memory, it's always mapped, and yeah, we will get smaller pages when we would like to have 2 megabyte MD mapping. So I'm not sure what's the right allocation policy would be for anonymous memory.
So I agree
From
with you.
what,
We don't have
from
to
what
sort
you said, sorry.
Go ahead, Hugh.
From what you said, it sounded as if you wanted something like file map pages, but for anonymous. And one can easily imagine having a tunable and the user space could choose to map in X number of pages when mapping in one. That would be a small change and wouldn't really interest this meeting. But from what you said, that sounded like it was enough.
How do we do that with an anonymous memory? So, do we use something like pre-fault in?
I was talking over you, so I didn't get what you asked.
So I'm trying to understand what you were suggesting.
Well, simply that if you get a fault on a single page, instead of just mapping in that single page, you map in a group of pages. And you have a syscontrol that says how many to do, and the default would be to do a single page, but in your case, you'd ask to do several.
So
Yes,
basically,
allocate.
Fold around for anonymous memory.
Like fault around for anonymous memory. But the problem is we also want those pages to come from a single location, single physical location, contiguous physical location, because this reduces external fragmentation.
Well, you can certainly set that up in your allocation policy.
And when we reclaim those pages, we also want to do it in one run instead of 8 times. So yes, right. I mean,
Okay, then you're.
Yeah, right. Because you have 8 pages on the LRU list. You have to scan 8 pages. You have to go into the RMAP to look at 8 different PTEs. But in theory, because of memory locality, those 8 pages could be all have been used, or it could be all have been idle.
I accept those points, but what you said originally was that you wanted to fault, for you the significant thing was the number of faults, But yes, there are other advantages
Okay.
if you condense into a single page. But those sounded like they weren't, that they were minor compared with what you're interested in.
I think the missing piece is maybe why this wouldn't be possible today, right? We do compound allocations for anonymous. You can fault larger pages in, and we put the head page on the LRU and reclaim it by the size of the compound order.
I think we have in few places assumptions like the compound pages on LRU is order 9 or something. So there can be a few places where we need to deal with that.
How many places are there that just do H page number pages or something?
Well, so probably they don't do H page LR pages. They see they just test is compound.
Yeah, like split huge page will not be happy right now, I believe, to see non-order 9. Or was it fixed, Matthew?
I may have fixed it, or I may only have fixed it for file pages. I'm not sure.
Okay.
I'd have to check.
A notable place that always crosses my mind, the page vex. If they see a compound page, they only do one page. That should be changed to look to see the extent that it's dealing with. That was a change made for the stats getting too far out when you had 15 huge pages on the page vec. But if you've got 15 order 1 pages on the page vec, you really shouldn't be dealing with them one by one.
For compound page, we bypass page vec, no? We go through like directly, we don't really cache them. And
Depends which part of the kernel you talk about. Some places will pop them off the list and do something special with them. Some places will leave them on. It's a little ad hoc.
Then we also need to find a way to map this compound page by PTEs. That's something we don't support right now.
I think we should.
Even though we have a PTE pointing to one of subpages in this compound page, we don't know, because when we see this compound page, it's not a huge page. And we just assume it's going to be a base page or a small page. We don't have something in between. We don't know, oh, okay, this is a compound page of order 6, and we need to deal it as such. So there's a head, and this one, maybe a head page or maybe a tail page, and we can't always assume it's a head page or it's a base page.
Right, I think it's right now it's a bit of a mix. I think pretty much everybody checks page trans compound. Some of them just directly called compound order, which I think would already work. I think there are a few cases that check page trans compound and then make the assumption of what that size is. And I mean, like uppercase page size, right? We just have to track those down anyway. One way or another, we have to track those down and say, check compound order to see what the actual size is. But I mean, the checks are in place, right? It's not like we're looking at a page and being confused about what it is. It's just we're making an incorrect assumption about the size. But I think we're not doing that in a whole lot of places.
like we assume that page trans huge is really mappable. But yeah, with this approach, it will not be the case. One other like corner case we should be aware of is we shouldn't allocate order 1 compound pages because it will cause issues. Like we use space in second tail page and such. So order 1 should be avoided.
I think also the PTE mapped compound page also maybe conflict with current double map, because I think for like the PMD, we always have the PMD map first, then we have the PT map to the all the 9 pages. That's the assumption we have now. So if we have this compound page only mapped by PTE, since that is kind of different from what we have right now, right?
Should be fine. We just will start with compound map count 0 and map count of subpages will set according to
Because I
how.
remember there is some code place say there is always starting with PMD mapping, not the PTE mapping. So in this way, this is always starting from PTE mapping. So there is some assumption.
Yes, there is corner case that, like, yes, anonymous memory always starts with. So anonymous pages, CHP relies that we never come from compound map count 0 to compound 1, the compound map count 1 or greater. So compound map count will never increase. So if you have compound page order below 9, you will have compound map count 0 from the start, and double map will be clear, and it should work.
And I'm not saying that we can't do this today. It's just my hope is just, we could leverage something that is type safe, because we personally, I think we're gonna if we keep going with what we have today, we're gonna be dealing with tail pages a lot more often if we want to support medium-sized pages.
Right. So I think that using folios in anonymous memory is right way to go. Probably I don't know. Johannes has different idea about that, but yeah, I don't think it's directly tied to what you propose. I mean, we can convert first anonymous memory to folios and then allow to allocate pages other than other 9 for anonymous memory, or we start other way around. I guess with folios at the start it will be easier, but yeah, there's not necessarily dependency like order in which it has to be done.
I mean, I think my stance, since I suppose I'm the most vocal opponent of like a shared portfolio, shared folio for everything. I don't know, maybe I can outline my stance a bit, because I think it was confusing in the past and not everybody understands what I'm actually saying. So I'm not opposed to type safety at all. I think it's actually a really good idea, and that's why I'm involved and still am involved with the patches and like also with the offshoots of it. Like I think everybody agrees that like struct page is pretty bad the way it's overloaded right now, and one of the instances of the confusion of what a struct page is the head and tail page thing, right? But I mean, it goes far beyond that, right? It's a much broader problem. Is like it's a struct that's a union of other structs, and then even inside those structs, we have type pointers where the type is bullshit, right? You have something like the mapping pointer, which is a struct address space pointer, and it points to an anonymous VMA half the time, right? So there's a lot of confusion, I think, about or black magic of how to like, you get a struct page and it's a range of bits, and to interpret them, it's basically black magic, right? And head and tail page are one of these problems. And I really like the folio approach of taking different types to split up and clean this up. But I think head and tail page are only one aspect, and the size as well, right? You look at a random page in an MM function, right? You're asking a whole lot of questions like, is this anonymous? Is this file? Is this slab? And then once you're past that, you're asking like, is this a head or tail page? What is the size of this, right? There's all these questions, but head or tail is only one aspect of it. And I would wager it's actually one of the less prominent identities of a page, right? If you go through a thought experiment, right, and say, you make a word cloud of all the different things that a page can be, right? All these identities, right? It can be anonymous, it can be file, it can be header, tail, it can be reserved, unreserved, it can be all of these things, right? Network, slab, you name it. But then if you go through code one by one, right? And the size of each word is basically how often do you have to make the distinction between or infer the identity of that page, multiplied by how important and how complex are the implications of this, right? So for example, if you walk through the compaction code, right, you start with a random PFN. So the first question you ask, like, is this header or tail? Because that determines what can I actually look at in struct page, right? So that's 1 point for head tail disambiguation, right? But if it's a tail page, it's actually really simple, because the only thing you do is either you skip it because compaction doesn't care about tail pages, or you say do compound head and go to the head page, right? Also very simple, because usually nobody deals with tail pages. So 1 point for disambiguating that, but it's not a whole lot of weight, just because like it's not very complex. And then you move on, right? You isolate the page from the LRU, and you go enter generic migration code. Now you have to do a whole lot of stuff to the page, right? You have to lock it, you have to remove it from all these data structures, you have to unmap it from the page tables, you have to release the page, which depending on where it's sit, right, you have to inform a whole bunch of things. You have to inform the swap code, you have to inform the file systems, right? So first of all, how do you lock a page, right? Is it anonymous? Well, you don't really lock it, because anonymous doesn't use lock page unless it's in the swap cache, then you have to lock it, and so forth, right? So the distinction between anonymous and file is very complicated. It happens all the time, and the consequences of being of that type are complicated, right? You have to think about how to lock it. If it's a file system page, you have to remove from the file system, you have to remove from the page cache, you have to let the file system know I'm releasing this thing. You have to deal with write back, you have to deal with all of these things. Now you also have to unmap it from the page table, and that's one where you have to make another distinction. Is this a head or a tail page because of the way the map count is implemented, right? So if you do this kind of like word cloud of page identities, right, you're getting huge words for anon and file and maybe slab and maybe network, and you're also getting head and tail, but it's tiny, right? It's a tiny factor. It's a very rare identity you actually have to identify, that you actually have to assert. And the thing that I don't like about a shared folio is that it takes that like not very prominent aspect of the page and makes it like the main thing to identify the page by. Right? It's almost like you're going to a hotel breakfast buffet and you ask, what type of cereal is this? And they say it's the kind without asbestos. Like, okay, that's not right. That just raises more questions that I asked, right? It picks like a minor thing. And I mean, it's not meaningless, obviously, right? It's meaningful whether it's a head or a tail, but it's not the most prominent thing. If you read any random MM code, right, and you see a struct page, you have a lot of questions. But usually, if it's a head or a tail page, is for me at least not even in the top 5, right? There's so much more going on. Is this anon? Is this file? What are the locking implications? What are the lifetime implications? Right. So I really like the idea of type safety, and I'm 6 months ago, I've been supportive of having like a page cache descriptor. I would also be supportive of having a separate anonymous page descriptor. The only thing I don't like is that we're taking something that's not very prominent identity of the page and making this the front and center part of the page, of the object we're passing around. And to me, I think that's why people have reacted to the folio name also like this. I don't think it's about the name. I think the name is actually really clever, right? When you want to describe something that's either one or more pages, right? Folio is a clever name, but one or more pages is not, if you look at any random MM context, that's not the most poignant way to describe the object you're passing around, right? That's not the primary identity you care about. Not to say that it doesn't matter, but if we want to pick a name for this thing we're passing around, I don't think that's what it should be. I don't think that's what we should structure everything around. So yeah, I think type safety makes sense to me. I would be fully on board with like splitting out struct anon page or whatever. Makes total sense to me.
I see that, yeah, types starting from isolating tail pages from the rest is right and most useful just because tail pages very rarely needed. You don't associate like identity of the page with tail or head because you rarely care about tail, and it causes problems if it tail. So yeah, I see that you want to go deeper and differentiate more, but it's the first like low-hanging fruit that brings real benefit without disturbing how we handle pages in general. We just want to make sure that we don't see tail pages as code path, and it's useful.
But I mean, it almost seems like a rounding error to tail pages, right? I mean, how many times do you really see? So I think one problem we have is that we have these low-level page flags helpers, right? And we do a lot of compound head translation in lower levels of the. But if you do what I did with the slap page flag, and you bubble those compound heads up into the caller, you can immediately tell that 99% of them are completely unnecessary, right? If you do this, for example, Hugh has done this for page active, if I remember, and I don't know what his experience was, but if you take something like page active, for example, right, and you say every single tester of page active now has to have compound head first, and then you remove it from the page flag, right? You bubble up into the caller. You can delete all of them. Right, it's LRU code. There's no tail pages on the LRU. It's super easy to rule out and just delete all of them. Like
except for places where it's not, right? That's the thing.
But
it's super easy
which
until
are
you
those?
try and test it. Sorry.
Like which ones are ambiguous and which ones are left?
There was one that came from somebody calling pfn to head. Sorry, pfn to page. And that's the problem. I mean, that's what I'm addressing with Folios, is that if you call PFN to Folio, you definitely don't have a tail page. I mean, the thing is, okay, I mean, your word count is a great way to illustrate your point, and I understand why you see it. I understand why you see it the way that you do. But we've had since I started working on Folios, I found 4 bugs. No, wait, 5 bugs. Some of them consequential, some of them not, but they were all confusion between head and tail pages. And I think just getting rid of those bugs and making sure those bugs can't occur again in the future is worth it.
And
Look
also,
at any
I
piece
think
of kernel code for longer than 5 minutes and you'll find bugs.
I mean, in the process of this, right, when I wrote up the confusion between anon and file, where I tried to make the point that this is more prominent, that's a more prominent identity disambiguation, I also immediately found bugs in BMScan. Right? So we're actually totally on the same page when it comes to type safety, right? I do think we would fix a lot of bugs. I just think we would fix more bugs with a struct anon page, with a file page, than we would do with Folio. And I mean, I totally get the point too, right? That we could start with the one and then do the other, but it's just.
Johannes, how do you see handling like a code path where we don't care whether it's anonymous or file pages? Do we create like 2 separate code paths for them, or we have base type or something?
No, I think those would still be using either a generic struct page. I think for tail pages, it really comes down to the entry points, right? If you, for example, swap.c, right? It's a misnomer. It's mostly LRU handling, right? It just handles pages that are on the LRU. It doesn't really care if this is anonymous or file. It doesn't really check for them. It just deals with this thing has been accessed, put it to the head of the LRU. This thing is being added as a newly allocated page, put it to. And then it has like one check: is this anonymous or is this a file LRU thing? No, there's no confusion about tail pages in the entire code, because if you start out with saying I'm allocating an anonymous page and I'm adding a struct anon page to the LRU, you could have the entire swap.c operate on like a generic type, right? On a struct page that still has like a list LRU or something, a list head or something, right? And there would be no confusion about a head or a tail page. Head or tail page really exists in a few places where you're coming from a physical address space, right? PFN to head, PFN to page is a really good marker, right? That's, you obviously know, you, unless you've actually verified what PFN this is, you need to check what this is. It's, I think, the same for vert to page, right? That's another clear, like, you don't know what you're looking at. But once you've actually verified it, right? If you have higher level code that only deals in page cache pages, there's not really a confusion, because you're starting out with a head page. You're starting out with it, unless you're coming from the PFN range. Who's dealing with tail pages? Right? There might be a couple instances, but in terms of like entry points into code, right? They're very manageable.
You say there are no confusion, but if there's no special type and you use struct page, then it means those unnecessary compound heads embedded in various flag operations.
But where do you need them?
It makes sense to
so you are saying you are trying to isolate this compound and head page and tail page using the code. So the tail page only happens in certain files or certain functions. So the rest of the places are all dealing with head page. So, but Folio just take a step further using the type to tell people, okay, this is definitely the head page. There's not going to be tail page. So I'm just thinking this might be clear, since if there are new function adding to the kernel, so how are we guarantee that, okay, this function is definitely not touching any tail page, it's only touching the head page? So that's, we'll need a detailed review and check when any new functions touching the structure page in the future.
Well, I think that narrative is based on the idea that we have a healthy mixture of high-level pages or head pages and tail pages, and basically the confusion is everywhere. I don't think that's true. I think here, whether we bubble up compound head by hand or whether we use Folio to do this, I mean, the outcome would be the same, right? We have them eliminated from the place where we don't want them, and then there's a couple places where we will have compound heads left, right? Regardless of how we get there, that's the outcome. I think the really interesting ones, though, the places where we really do need to put thought in is where they will be left, right? Places that do have to deal with compound heads. And I think those will be very few. There might be some that are unnecessary right now. And I think it's probably useful to invest in them and see if they're just confused about what they're doing. I mean, we also have situations, right, where we start from a tail page, but we never kind of resolve it or clean it up. So we have like a PFN to page, and it's a tail page, and then we use all these like page flags operations and test against it and rely on the fact that they're all going to the head page, right? But code like that, it really should go, hey, I'm coming from a PFN, I'm resolving this to a proper page once and for all. And like, that's the scope. I'm not letting it bleed out of that scope, right? And this has been my contention. Like, obviously, yeah, type would make that clear too. But if like 99.9% of the instances are the new type, then what do you need the new type for, right? You look at a random struct page, there's no confusion. It's a rounding error.
You need the new type to prevent future bugs. Because, okay, I mean, let's take your page slab series, right? You've gone through and converted everything right now. You've done nothing to prevent somebody coming along in the future and saying foo to page, or let's say vert to page since it's slab, and then calling page slab on it.
But who's doing that? Why does this even have to be a public function?
Some future piece of code. Oh, well, page slab is currently a public piece of code.
To me, that sounds almost like on the same level as somebody casting a random struct page to a folio.
Yeah, but
like,
we've given them all the pieces, right? We've given them vert to page, and we haven't said, oh, hey, vert to page, that's kind of risky. You probably really know. You should be calling vert to head page. That's what you really want to do.
Yeah, but why is this hard to do? Like, is this hard to do?
The Cassandra people got it wrong.
I don't think they did.
They did. I found one. I just submitted a patch for it.
Okay,
it's
but
in
if
Auto
we're
Stream.
saying struct page by itself, right? A tail page is not really a meaningful thing. Why are we exporting like a generic API to look it up? Like obviously you can get it with the new type, but the whole point is like we can also just hide vert to page and say this is like an internal function for if you're in the business of sparse memory, memmap management, stuff like that.
So you want vert page to become so private that even people working on KA-SAN won't be able to see it.
Yeah, why not? I mean,
I think that's great. I just don't know what your concrete proposal is to actually make that happen. I mean, you can put in mm/internal.h.
Okay,
but
I also
not...
I don't see the alternative. Is KSAN going to use Folios?
Yeah, why not?
But, I mean,
because the intent is that we let's assume we don't do all the splitting out struct page, right? Splitting out struct page into SAP, which I think we should, and you know, let's just put all that to one side. Let's suppose we just do struct folio, which contains everything that struct page has, and struct page goes to just containing compound head, right? Then we can leave vert to page as something which exists. But okay, now you have a struct page. What can you do with it? Literally, the only thing you can do with it is pass it to compound head, or any other function which is going to take a struct page. And in this future, there wouldn't be a lot of those, and pretty much any that did exist would be calling compound head for you.
But I mean, okay, then it really depends on how struct folio would look like. I think if we split out, the more types we split out, and this would be good things on their own, but the more types we split out, the less generic you can implement code for folio, right? That's also true. But if we leave everything in the folio, then we still have the problem that I went back to earlier, right? We have a super overloaded, inscrutable structure, and the more we leave everything in there and just clean up the head and tail, the more we're leaving the other the other page type confusions in place, right? It's not just head and tail. Like I said earlier, there's many identities a page can have. And
can we build on top of folio? Like say folio is just for tail and head, and other you have an anonymous folio, file folio. So I think these two are just orthogonal thing, right? One is about type of the pages. The other is it's a head page or tail page. So I think this is why I see the difference between the folio and what you say about the different types of pages.
But I mean, aren't they solving the same problem? You're looking at a pointer to a thing that you don't know what it is, right? You have to figure out if it's a head or tail page, and you have to figure out if it's an anonymous page, and then you have to figure out and so forth. Right? To me, it sounds like it's solving the exact problem. And one thing, like the head and tail thing, is much newer. I think that's why we give it much more scrutiny, because we've had the other thing for a long time, and we're kind of used to it. And we've lived or like made it work without type safety. And I think the head and tail page thing, because of anonymous, compound pages have been around for a while, right? I think because of THP, they've just been more prominent. And obviously, if we go into the file cache, it's also going to be more prominent. But I don't think it's a different class of problem than the other things.
So what you're saying is like different type pages have different types, always the head, and internally they have the function to convert, say, PFN or different struct page from either tail or head to that specific anonymous page or file page, something like that. So anyone operate on those specific page types will not see tail pages. So you see that's the way of solving this tail page problem. Is that what you're trying to say?
Right. Yeah. I mean, it would solve the tail page problem as well as the bigger identity questions around struct page, I think.
So I think historically the only way to go is to go incrementally, and even though you consider the head and tail page thing to be minor. It is a incremental improvement, and it has already been coded. So why cannot we just proceed with that and then focus on the other stuff? The further splitting of a non-env file. Why is it a problem to start with the folios which are done and could be merged? Just because it's minor in your consideration?
I think for me, it just comes down to the disruptiveness of the changes and the benefits they provide. Like I said from the beginning, I don't think there's no value to them. I think there is definitely value in cleaning up the head and tail page confusion. My contention has always been if we touch all, like thousands of lines of code anyway, what I mean, like it's just a lot of churn, and the transitionary period of like where some code deals with the page and some code deals with the folio. It's just, I don't know. I've definitely found myself like while having the discussion and while reading the code just to check out like earlier versions of the code, because I just couldn't read the hybrid code where sometimes we have folios and sometimes we have pages, and then some helpers have disappeared or been renamed. I found it just very difficult. So it's just an immediate code impact, right? It's not the incremental thing. It's just the immediate impact on the code base without a clear like where's this headed? Because okay, so if we have everything in the folio, and then it's to me unclear what struct page is still doing, and as long as that's kind of unclear, it's not clear how long and how much of the page API we have to keep around, right? So basically, we're gonna be. I mean, I don't know. I think my fear is that we would be stuck with like this hybrid, both the folio API, both the page API, while we're quibbling which data, like which member should go where. And in the meantime, right, we still have to run this code on kernels. We still have to be able to go in and debug stuff and make sense of everything. I think that's just been my, like, if this were like an academic project and we have like the ability to infinitely refactor, I think this wouldn't be really a problem. I don't think it is as incremental as you say. I don't think it's as incremental as you say.
Yeah, I guess probably we need to take even a step further to decrease the amount of structure page used in the kernel. So we mainly use the struct folio. So the structure page only, we constrain use of it for only like head page when we're converting tail page to head page. So we make struct folio the most used data structure in kernel to manage pages. So then the structure page can just go away when we only handling when we want to distinguish head and tail pages. So in that way, all the kernel code deal with struct folio, then that should be kind of isolate all this head and tail page to very minimal code.
Right. I mean that's the idea, right? But I think whatever, that's why I said earlier, I think whatever is going to be left over after we convert it, that's where it gets really interesting, right? Because we've had this discussion on the list, like who's left with like struct page after all this, right? And like we had a couple things that came up, like the bio came up, the page fault handler came up. Like people call lock page and expect it to lock the head page, right? There's a couple of things where it's like it's not entirely like that's definitely the goal. I think that makes a lot of sense. But it's not clear if we can actually get there, because I think there are corner cases where we're not entirely sure yet what is going to be left of struct page and what is going to remain in it.
I think struct page remains wherever we need to refer to a specific 4K chunk of memory.
I think there's one danger of what Johannes is, I think, proposing is if we end up with a separate type for everything, we end up with a duplicate set of conversion routines for everything. Because with the folio, we have a set of conversion routines that everything can theoretically use. But if we have folios for files, we have another one for non-pages, another one for, I don't know, swap, another one for networking, we might end up with duplicate sets of conversion routines for everything.
So I'm fine with, there being a subclass of folios for anonymous. I think struct a non-folio or even just struct a non would be fine. I would be leery of us going much further. I don't want to see a struct AFS folio, which is definitely a pointer to a folio which belongs to the AFS file system. I mean, it's kind of tempting, right? Because then you can hijack the private pointer, and it can be a pointer to the data structure of your choice. But I think we're just as well to leave that as being a void star, and understanding that private means it's private to the file system. But we definitely do.
So
need,
I mean, I think I understand.
I think we do need a type, which means this is the head page of a chunk of memory which is mapped to user space, because we do have these walkers which walk PTEs. We do have these walkers which walk the mem map, and those need to be converting to a type which is somewhat indeterminate, and I think the name for that type is folio.
Right, so it wouldn't be any head or tail page. It would be like a struct mappable, basically. See, I think this is where I get where to me it gets confusing, right? Because we have these discussions, and then you make a generic statement that says folio was only ever about head and tail page. But I don't think that's quite true. I think the file system people have said, like, we don't want slap in there, right? Okay, now you said it should be what's user mappable. That's also not slap, right? So it's not as generic as I think originally it was conceived. I think we've already kind of changed it to something where you say mappable to user space. That's what it should cover.
So actually, no, my original idea really was just head. Struct folio was a head. I had no intention of splitting out struct slab. Kent pushed me in that direction, and I was willing to go along with it because I can see the advantages of it. And it seemed like a good way to demonstrate the principles of, hey, you can split this out and then good things happen. I mean, the good things happen, the easiness to understand is not happening for struct page until we've converted every single file system, right? Which is going to be years. But I feel like we should start, right? I mean, the best time to do this was 20 years ago. The second best time is now.
I do think we should start. I think one of the reasons why I really like the struct slab is because I think it's an excellent test balloon of us figuring out what should be where, right? Not just to get started, but really to figure out, hey, are we really considering all these cases of like what about the node ID, for example, right? Where should this be? Where should things be that? Because I mean, folio is still going to be a derivative of struct page, right? There's a couple things that apply both to the folio and to struct page, and I think there's a good question of how do we handle this. I think my concern is to say struct folio is just everything the struct page is except for head and tail pages. That I think we're just kind of locking us into the same confusion that struct page had with all the types. Again, like I said, I mean, I think head and tail page are just one of the many confusions we have around struct page, and they're real, but I don't think they're the most prominent. I'm a little worried that we're taking an idea and we're locking us into something, whereas the surface area of saying struct folio is just about anything, file system, anonymous, everything, is that we're kind of locking us into the same continued confusion of like, you're getting a struct folio and you have no idea what it is. The only thing you know is it's not a tail page, but everything else is still as confusing as struct pages today. And you still, I think that's part of the reason. I don't know, and again, this could be me overreading it totally. I think to me it always felt like the reason why the file system people are so all over the folio is because they said basically the only thing we know for sure about this freaking thing that you're sending us is that it's page size and size, and if you're taking away that, we're going to throw a fit, right? Because
actually, I'd rather not deal with pages at all, to be honest. I don't care if it's page sized or bite sized or something. And the stuff I'm looking at doing, I'm going to be dealing with multiple pages glued together, and actually pages start to become a problem.
Right. Yeah. I don't know. I don't know if I misread it. That's always how it felt to me. Like, yeah, head and tail page is an instance of the struct page mess. It's not a new class of problem. It's just a very recent one. But it seems to me the type, like this idea of breaking it out into types is just a really great idea. I think it would be nice to like take advantage of it. But would it not be incremental to say we're doing folio for the file systems and we see how that goes? And because I mean, I think there are still a lot of questions around, like, when do we transition from, like, first of all, how do we handle shared state, right? Because right now the folio is in a union with page, right? It's not clearly a separate type, right? So I think there's still, I think that doesn't help in clarifying what the folio is and how it's different from the page in terms of the actual members in it. That's why I wonder if we do merge the file system bits now and we see how that goes and we figure out what needs to live where and how we can actually separate those types more, then we can still do, like, if we end up saying, hey, actually this has a lot in common with anonymous and we can share it, and I don't really see a harm in then merging exactly what we have today. But it might well be that we end up saying this is not the right format yet, and instead of having to change everything, we just have to change the way file systems operate.
So you say that we can merge folios without the anonymous bits, right?
Yeah, I mean, that's what I said
And
6
then-
months ago. I would be totally happy with this. As I said, I really like the idea of type safety when it comes to that. I'm not, but that's also the reason why I'm not a big fan of having folio be as complex as struct page modulo that one thing about head and tail pages.
I think that's more an implementation detail, because it has to fit over, basically be co-located with the struct page.
Oh yeah, absolutely. I do think it's an implementation detail, but at the same time, I think it gets in the way of clearly understanding what the type is now and what it's supposed to be.
Personally, I haven't had a particular problem with that. It's been fairly smooth. I've got AFS working on it with no particular problems. What I do like is the ability to have glued together bunches of pages to up performance. But I don't see any of the other types in the memory management types.
So you say you're fine without anonymous bits, but Matthew wasn't.
I don't really
thrilled about
encounter them. Yeah, I don't
Well,
encounter them.
We've got you here saying that that folios make it easier to convert to use larger pages for anonymous as well.
But that
So I'm
doesn't
thinking
have to
how
be done
can we
right
start
now.
incrementally moving on with. I'm sorry.
So I was saying that doesn't have to be done right now. You see some advantage to that, but does that have to hold? If the file system people really want folios, and the MM people aren't so keen on or aren't so sure about the anonymous side of it yet, What's the need to tie them together?
Yeah, I'm thinking how we can move forward incrementally, because either we can like do that without the anonymous parts, or we can try to imagine how further we can reshuffle everything and stitch struct pages all together and have just array of 1 or 2 pointers. But I think that's maybe too large change, and we could debate it for 5 more years. Or so what I'm asking is if Matthew would be okay with, like, for now removing the anonymous bits so the rest can be merged, or what can we really do at this moment?
Who are you asking?
Matthew, did I say Matthew or?
Yeah, you did. So I'm not really a fan of doing a lot of conversions between, we're going with what an interface uses, starts out with a page, it converts to a folio, back to a page, back to a folio. And the parts that Johannes objected to, if I remember correctly, are the parts which would do that. We would end up converting page, folio, page, folio, page, folio. And it's like, well, why? I mean, once a routine's been audited for actually being multiple orders safe, I convert it to folio and then I know it's done. Whereas anything that's still using struct page, I treat as suspicious that it may well be assuming order 0 or order 9, and so it's actually a great way to ensure that things have actually been converted and understand that a folio could be of any order.
I think one thing that you mentioned, the back and forth, is something we do have in the current folio patch set, though. Like, for example, the man, I forgot what it was, but I mean, there's shared code, right, where both file pages and anon pages get passed in, and I think the because from the page cache side, you're coming with a folio, and then below, inside that code, it goes back to a page. And then the swap side, who's using that same code, is first converting to a folio and then converts it back, because the shared infrastructure is now for folio, but it uses pages underneath still. So I think in terms of clear delineation line between the page and the folio, I don't think it would be a regression to drop the anonymous bits. At least from the code that I read, it seems it's already kind of murky of where the handover is right now.
I feel like we probably need to be discussing this with the actual code right in front of us, rather than saying, "Well, I think and I remember that."
Yeah, I think it was the working set code where you have the file system is passing in folios, and then the working set code takes a folio, and then internally it does stuff. I think it looks at the page and does stuff to the page. And then the swap, because the swap, I think it's the swap fault path, because it's not converted yet. It starts with a page, then it calls page folio to call the working set code, and the working set code goes back to folio page. So we do have a couple of, like, we're halfway migrated, right? And I think this applies in a couple places where the files are coming in as folios, and then the underlying infrastructure is still doing page conversions. I mean, I think it's just a matter of incremental.
I have like 50 more patches that aren't queued up for this release or next one. So it's like, yeah, there's the conversion is definitely not all done yet.
No, I mean, it wasn't. I didn't mean it as a criticism. I'm just saying, I think like the line of scrimmage is not entirely clear yet. I think it's not going to be one way or another. And I think it would actually be easier probably to draw it if the folio we would use for files now, because we knew, okay, every time it goes into shared infrastructure, it's clearly just page, right? Yeah, and it wouldn't solve the head and tail page thing for now, but I think it would help delineate the current folio and say, hey, this is a file thing. And then we could have this, we could move ahead with the file system side, and we can figure out how this type actually plays out in practice, this new type. To me, that sounds like an incremental step.
And I'd really like to work out whether we're getting this in or out, because it's not, I've got stuff pending on this and other people have stuff pending on this. And it's like, do we adapt our stuff for it or not? It's real pain not knowing.
By the way, is it still part of Next, Linux Next, or?
Yeah, I updated the tree to, I think, RC3, but it's fundamentally the same pull request that I sent last time.
I mean, I think it comes down to whether we want to have consensus on the MM side or not. I mean, I'm sure Linus would maybe pull it anyway, but I don't think we have consensus on the MM side, and we do have on the file system side. So I mean, it really comes down to are we willing to split it and make everybody happy, or are we willing to walk over people? I think that's what it comes down to.
I think Linus said he wants to see a consensus. So. So the question is if we are willing to remove the anonymous bits, and probably it would have to be done quickly, so it can have like 3 more weeks in Next before the merge window.
Yeah, I'll take a look, but you know, it's getting awfully late in the cycle for this.
More like 2 weeks at this point.
Because I'm not sure that's one option if we want it merged next merge window, and the other option is to convince Johannes that it can be merged with the anonymous bits. Or are there others?
This doesn't seem working.
Sorry?
This doesn't seem working. I mean, convincing Johannes. Okay, folks, it's 10 past 8 here, so I need to go.
Thanks for staying on, and thanks everyone for coming. I'll stop the recording now.